Morning, everyone. Um, I'm really glad that you all joined our today's session of the Center for Sustainability Circular Industries Hub Circular Industries Talks. And today we have with us Derk-Jan van Heerden. Derk-Jan is a former CEO of Aircraft End-of-Life Solutions. And he is also the founding father of Aethos. I'm not sure whether I pronounce that correctly.
Aethos.
Yeah, right. That is focused on the recycling of airplanes. And it's also one of the participants in the Green Skies thesis lab that we do together with NLR and Collins Aerospace in CFS. So I'm really happy that you're willing to share your insights today, Derk-Jan, on the recycling of airplanes. And yeah, without further ado, I would just like to give you the floor.
Thank you very much. I'm not sure if I can see you guys when I start the presentation.
No. We can see you, and I can see everyone at the moment.
But, yeah. So if everybody falls asleep, I don't see it. But if it's too boring, let me know, because then shake me up, and I'll do my best to at least tell you a story you're interested in. Aircraft material recycling, that's what I want to talk to you about. And also I wanted to present to you what hurdles in the aviation sector. I'm hoping that you might be able to help me. I'm assuming that a lot of you are interested in the subject recycling. So that is what this is about. This is an example picture. This is an airplane that is disassembled by AELS, Aircraft End-of-Life Solutions, the company I founded in 2006. And this is the example where this discussion will go about. Because it's relatively easy to disassemble an airplane, remove parts that can then be reused to keep airplanes flying. There's also something that we call alternative reuse. For example, you can see here areas being cut out, such as the cockpit in front. That is alternatively reused, that's being built to a simulator builder or into keychains or something like that. But then there's still something left. And Aethos is trying to ask people, what can we do better with the materials that are left after all the parts from reuse moved. The presentation, I will first tell you a little bit about myself so that you know who I am, what my history is. Then I will discuss a little bit more about aircraft end of life, and then also about material recycling. I studied aerospace engineering at the best faculty, the best university of Delft, the Netherlands, Europe, and the world, if you ask me. And I graduated in 2005 with my master thesis subject with the title End-of-Life Aircraft. You see a little bit of the document I created on this slide, and also on top you see the 747 that was part of my project and that I helped being disassembled and recycled in 2005. Directly after me studying at the TU Delft, I started an own company that got the name AELS, and I also was part of AFRA, the Aircraft Recycling Association, which is a grants organization for people that are busy in recycling airplanes. And I started Aethos in 23, so last year. A little bit more about AELS. I remembered that when I graduated, I had the idea to call the company Aero Scrap, but the idea was also reuse, and using the word scrap for reuse doesn't really work. That's why directly after that, I changed the name into AELS. And that's also, some people think you need to pronounce it as a word, and then it doesn't work. So that's also one of those names that might not be smart, but then again, it might also be smart that it's a difficult word to pronounce. So that's why AELS was founded in 2006. I initially started the idea of doing it as a service. That did not work very well because aircraft owners basically wants to stop being an owner and they just want to get rid of it. So I started buying airplanes, then disassemble them, and then remarket those parts that can be reused, and then give a good solution for everything that's left. But I started with old aircraft, but that was not enough to get the financial model of the company working. So lucky enough, I was so successful to make a next step, which was buying a new old aircraft. And I also moved the company to Twente Airport. And the picture you see here is the first aircraft that arrived there, an A340 from Swiss. And the company is still very successful. The next slide, you will see the airplane that arrived yesterday, which is the first Transavia 777-700 that is going to be disassembled there in the coming weeks. And also a lot of those parts will be reused, and everything that's left will then get a solution that is available now. But hopefully also steps are being tried and figured out to improve the recycling. Next to who I am, I also want to share with you maybe a little bit of a sad story, and that is that I got the flu in February last year, but the doctor very quickly said, no, you don't have the flu, you have a burnout, so take steps away from your company. That's what I did. But unfortunately, that was not the reason. I have a cancer in my brain. And as a result, there is no solution for that cancer that I have. So the only thing I do have is extra time. And I'm just trying to have as much fun as possible with friends and family and with people that are interested in also this subject. And together now with the team, I started Aethos with the idea to help the world a little step forward in a more sustainable environment. So the team now consists of 7 people. You got myself and Sikko Santama, who's also the professor I graduated with in 2005. I do have a picture of that I found recently, but I look way too young. And also my time wasn't correct, so that's why I'm not showing it to you. But then there were 3 other people part of the board. And Miske is fantastic, helping me in building the organization, and Michiel is helping me with doing the research and getting projects started, which is also way more challenging than I expected. So to tell you a little bit more, the reuse of parts from an aircraft that stops flying is, strangely enough, extremely well business. Why? The older the aircraft is, the more difficult it will be to find a spare part, because the manufacturer already moved to producing another part. For example, a newer screen or a newer pump. And as a result, when you fly an older airplane, finding a replacement part can be challenging. That's why older airplanes are disassembled to support a little bit less older airplanes that keep flying. However, that also results in stuff that can't be reused. For example, parts that never break down or are part of the big structure, and that then needs to be recycled. That is extremely difficult, and it's getting more difficult as well. And I will explain a little bit more about that during this presentation. It is, however, also very difficult to make a profit if you only do the recycling. That's why this foundation got started as a foundation, because we feel that those steps forward is not a business model. It's just something that the aviation sector globally need to agree. Let's see what how we can raise the bar. And that's why this foundation got started. How can we recycle better? That's the question that we're focusing on. And to give you an idea, we're also officially an OMBI, making sure that the donations we are getting are as good as possible for people who give donations. Let's dive a little bit more into aircraft. You got a new airplane, and eventually it becomes older, obviously. On average, the age of 25 years, that is the average that people always talk about. Some models stop flying earlier, some other models maybe get longer because there is a cargo conversion program for it, or there is not a good replacement aircraft available. But 25 is still the average, if you ask me, though I still believe that the average will go down. At the moment, people think the average will go up again because of the challenges the producers are having producing enough airplanes. But when an airline decides to stop flying an airplane, you will end up in the decision process. For example, you're an airline and you ordered a new airplane. Typically, you order two because all airlines are growing, so you replace one with two airplanes, or a smaller one with a bigger one. But then you are in the decision process. So in some cases, it flies back with another airline, keep on flying it. It's converted to a cargo airplane. But in some cases, you will decide that you're going to get rid of it and the airplane will not fly again. Then it will be disassembled. And with disassembly, I mean the removal of parts with the intention of reusing it to keep other airplanes flying. So that is reuse. As mentioned, if you disassemble an airplane, you're also stuck with something at the end, and that needs to be dismantled. That's at least a word I introduced back in 2005 already. That is what you do with everything that's left, and you try to figure out how can I get rid of it? Because, and I will explain this a little bit more later on as well, but the amount of money is so limited compared to the value of the parts. You just want to get rid of it as soon as possible. But then the question is, what is good? What is average? What is legislation behind it? And that differs. But the material needs to be processed, and then in theory, that material can be used to make new airplanes, and that is recycling. Unfortunately, the amount of materials that is recycled to make new airplanes is extremely low. Only a few metal types might be able to be recycled, but most materials are downcycled because they end up being used to produce something else, because the mix of materials that is used to make the airplane makes the recycling impossible or too expensive. So why is recycling not getting a lot of attention? When an airplane is designed, and I did aerospace engineering and some of you did it as well, so they will say it's the most difficult thing that there is. I agree, obviously. But that also means you can't optimize it in just one variable. You need to make choices in what is more important than the other one, and you always need to balance it out. When an airplane is designed, typically safety is also very important because the risk is a little bit higher than driving a car or riding a bike, requiring extra safety measures to prevent an airplane crashing down. But also cost, obviously, is very important. We want to fly as cheap as possible so that it is profitable and that passengers can also pay for it. Also, the sound is important, and I on purpose mention noise with a question mark because I don't consider it noise, obviously, but the sound needs to be also as low as possible, just to make sure that the neighbors are not too much waking up in the morning or late at night. Then also comfort is important. If you are flying a lot, you might feel that it's no longer called comfort, but yeah, we need to be able to have fun during the flight, eat something, watch a movie. So also that is one of those design elements that is part of defining the developing airplane. And another very important one is fuel consumption. So the lower the weight of the airplane, the lower amount of fuel that's being used to fly. That's why continuously they are trying to figure out to lower the weight of the airplane. If you look at that list, the word recycling is not on there because I've never spoken to anybody that is part of the designing of a section of an airplane that says, and we also include recycling. So it is a limited no element at all when an airplane is being designed. So we are now as a foundation trying to figure out how can we recycle better. And for the reason that airplanes are flying very long, we are not focusing on new aircraft. So we're not trying to find an answer as in, okay, nicely that we are manufacturing the material A, but why not make it from material B because that's very recyclable? Because that would mean that to getting it approved that new material that you want to use will eventually be a recycling solution when that airplane stops flying. So getting it certified, getting it organized, it will take 10, 15, 20 years. And then the airplane will be used for 20, 25 years. So then you will have a recycling advantage in 40, 50 years. That's why this foundation is only looking at the materials that are now already flying for the last 20, 25 years that were designed 40, 50 years ago. How can we improve the recycling of that old stuff in such a way that the waste that is being produced by airplanes that stop flying to get it as low as possible. Also, thank you to Richard to provide me these pictures, because this gives you a good idea about the amount of airplanes that are reaching end of life, and it's close to nothing, right? And there is this funny issue that I still don't get it why, because during the crisis, the Corona crisis, a lot of airplanes stopped flying, but the amount of airplanes being disassembled was decreased. There's a financial model behind it. I won't bother you too much with it, but it's still interesting to see that the amount of aircraft that are being disassembled is lower than was standard during the Corona, before Corona. And if you look at the picture below, which might not be very sharp for you, so I got that figured out in advance, the amount of airplanes that were parked increased, obviously, because everybody was staying at home, not flying a lot. But currently, the amount of airplanes that are still being parked, not flying, increased. So we were initially around 5–6% of the airplanes that are not flying. Currently, we're still around 10% of airplanes not flying. So there is a long, big pile of airplanes, of which is the question, will they ever fly again or not? And yes, there will airplanes being reactivated, but there will also be some airplanes that will never be reactivated. And why are they not recycled? Why do they keep parked? That's always one of those questions that is very interesting to dive into, because the reuse of parts is a good business, but then again, potentially the owner has a value attached to it, which is way higher than he can get for it, and that's why he keeps it parked. So let me then explain a little bit about that. Why is the recycling of airplanes something that sounds easy but needs to be improved? So I've got here 3 examples. One is you're disassembling an airplane of which a lot of them are still flying. Maybe some new aircraft are still added. So you're disassembling the first one manufactured, but they're still producing them. The other one is production stopped. Already 50% of the airplanes manufactured are no longer flying. And the third option is there is no value because you are missing the records. Because to be clear, to be able to reuse a component from an aircraft, the records needs to be complete. You need to be sure that everything you need to be able to reuse that part is complete, because a lot of parts on aircraft are life limited. Life limited means you are only allowed to use it so many flights, so many flying hours, or this calendar time. So you need to have a document and a trace to show that it was manufactured on date X, it has flown so many flights. All that information needs to be complete, which is a lot of work that needs to be done before reuse is possible. But if it's not there, you can throw it away. And that's why this is also an example I need to share with you. So let's dive a little bit in disassembly cost. So the newer the airplane is you're disassembling, the more expensive it is to disassemble, because you're going to remove everything that you want, because a lot of those parts are still in demand for. So you just remove more parts. The older airplane, a lot of parts are less being acquired by people who require spare parts, because certain parts break down once every 5 years, some once every year, and some once every quarter, and therefore the demand changes per part. So if 50% of the aircraft are disassembled, one of those parts already, so many are already warehoused and ready to be reused, that you adding one will only cost you money, and nobody would be interested in buying it from you, maybe never, meaning that investment isn't worth. So that's why the cost gets lower. And because, as mentioned, the airplane that has no records complete, you don't disassemble it. You don't remove the parts for reuse, for the reason that nobody can use it. So that's disassembly. Dismantling cost is therefore about how expensive is it to scrap the airplane that is left, so that you can recycle hopefully as much of materials as possible. And this is the average cost, roughly, with the current technology that's being used. And funny enough, the more parts you remove, the cheaper it is to dismantle it. The more parts that are on there, there might also be a lot of parts that are typically removed for reuse, but they also contain specific materials that you can't throw away easily. So you still need to remove it just to prevent that waste to be treated wrongly. So that's why the more less parts are removed, the more expensive it is to dismantle an airplane. Then the next question is about what is the value of the parts? So what is the money that you can earn when you sell the parts that you remove? And in this case, I'm not mentioning the engines because the engine life cycle is very different from the airframe cycle. So you could have an airplane with engines that are recently overhauled and therefore have high value versus engines that are run out. So in this example, just airplanes without the engines. And this is just an idea. The newer the airplane is, the lower the amount of available spare parts is, but also the higher the demand is, and that will increase the value. So you're paying, as an example, $5 million dollars or euros. There is not even mentioned here what coin it is, but just to give you an idea. The lower the airplane, the older the airplane is, the more aircraft are disassembled. All of a sudden, the availability of parts increases. So where in some cases, if you're disassembling one of the first one, you might be the only one with a spare part compared to the manufacturer. But if you are 50% airplanes assembled, there might be 10 parts available, meaning that the prices will go down. And as mentioned earlier, there is no value for reuse of parts if the records are not complete. What is then the situation with material values? And this is, I added pluses and the minuses. So there is a positive for the materials that can be recycled, where somebody is willing to pay for it, but there's also cost to dispose of the material that can't be recycled. This is the idea. And also, funny enough, the higher, the newer the aircraft that you're disassembling, and then the newer the model is, so there's still a lot of them flying, the more money you're going to get for the material. The older it is, the more spare parts that can't be reused, resulting in more waste streams that will cost money to get rid of. And therefore, the value of an airplane that you need to clean up completely will bring more cost, and therefore the material value will also be low. So if you add this up, then here you see the difference. As a company being active in the newer aircraft, yes, you require more money on your bank to be able to buy those airplanes, but the profitability chance is bigger and the demand is higher. The more aircraft that are already disassembled, the more challenging it will be to make a little bit of money out of it. That's why we believe that it's more important to also focus on the recycling, because those older airplanes, we're looking at more airplanes as well, the owner will start looking at the cost of the disassembly because it needs to be as cheap as possible, because the chance of him making a lot of money is way more challenging than when you are buying one of those newer airplanes. That's why Aethos is doing this research, to make sure that everybody understands that maybe somebody is willing to pay a little bit more for the aircraft, but you as a seller needs to make sure that the buyer is dealing with the waste stream in a good possible way to avoid waste treatment that are bad and recycling maximum as good as possible. And that is why I want to highlight this as well, because the reuse of components is a global market. Everybody that buys an airplane, disassembles it, he sells these parts to everybody all over the world. However, material recycling is local, meaning that you can use advanced technologies to better recycle, and which in Europe, obviously, recycling is way more important than many other locations in the world. However, not all of those processes bring extra money. A lot of them also bring extra cost. And those extra costs might also be obliged by law. If that is the case, the buyer of the airplane will have also extra cost. And then the seller might say, look, I can sell the airplane to that buyer, but he's paying more. And then he should wonder, why is he paying that? Because if that company is paying more because they can dump the waste in a way that is not decent enough, then they shouldn't sell those airplanes to him. So let me elaborate a little bit more about the challenges that I was just mentioning. The lowering weight and the increase of safety of aircraft is of course very important. But recyclability is not part of that. So there's always a debate that should be there, but that isn't there. As in, are we really want to improve the lower weight of the airplane, increase safety versus the recyclability? Yes, the answer is always yes. We want the airplanes to lower the weight, because lower weight means less fuel consumption, and safety, obviously, there's no discussion. If we can make the airplane move safer, then we definitely need that. But recyclability makes it that the result of that is that recyclability is more difficult. Then also the quantity of low materials. I will discuss it a little bit later on, and also special materials. I'll also mention a few examples of that. The quantity is low. What do I mean by that? Aviation is used to be special. We build airplanes, we are cool people, so we're used that everybody that sells something or does something for us appreciate us. However, funny enough, the recycling world is not that interested in aviation. Why? Let me explain that to you. Just an example of a number: narrow bodies versus wide bodies. Narrow bodies, single aisle; wide bodies, double aisle. Average 3 to 1. Then the average weight of those airplanes. Then let's assume 800 airplanes annually reaching end of life. 50% of the weight is being reused. The engine, the landing gears are very high valued, high weight, and as a result, a lot of those weight can be reused. And some of the material is not recyclable, meaning that on average, the total weight of material that can be recycled is 16.8 million kilograms. And that sounds maybe like a lot, but if you look at the number of the global amount of materials that can be recycled, it's close to nothing. To give you an idea, aviation, the waste of aviation is very small. If we would not only recycle the parts that can't be reused, but also include that. So let's say to a complete airplane, it's still nothing. And even if you take one step further and lower the total amount and just focus on aluminum only, it's 0.056% of the total material of aluminum that's being recycled annually globally is from aircraft that stop flying. And that makes it very challenging, because aircraft aluminum is not a standard way, standard aluminum, or in some cases it's also mixed and matched and attached, which makes recycling more challenging. And I also want to give you a few examples of special materials. The plastic that is being used, you might not be aware of it, but cars also used to have plastics in it that were so treated with fire retardant. Aircraft is used to doing that as well. So as a result, the plastic that comes from aircraft, if you sit in your seat and you've got all the plastic around you, that can't be recycled at the moment. Halon is still being used for the fire extinguisher, and halon has been pushed away from fridges a long time ago. So currently there is a shortage of halon, but why is it still being used? But that makes the reuse of the material very good, but it's still one of those funny stories that aviation sticks to old stuff, and replacing is always a big debate. So yes, the question is, are they saying we can't replace it because there is no alternative material to make it possible? Or are they just afraid of the cost of replacing it and then losing the investment they've done many years ago to get active in that material and that product before that? There are special unique aluminum alloys, and they're also attached to each other, making it also very difficult to recycle it. Chrome 6 is used in the paint, which potentially could also mean that the aluminum recycling becomes impossible. Then the current airplanes are made of carbon fiber reinforced plastic, which is fantastic because the weight of the airplane is decreased. As a result, less fuel is being used, but can be recycled. I know that since they introduced this airplane, roughly around the moment I graduated, the idea was to also recycle the production waste, which is relatively clean. But that material, that process is also still trying to find a good workable model. And if you recycle an airplane that stops flying, the first 787 has now also been recycled. The only solution that is available for carbon fiber is landfilling, because of the fact that the energy production of melting plastics for carbon fiber is it will cost you energy to burn it. So as a result, the only solution that I know of now for carbon fiber reinforced plastic made aircraft sections can only be landfilled. And that's not something to be proud of. And then the final example I wanted to show you with fuel, because reuse of recycling of fuel should be relatively easy, which is technically also relatively easy because you can get the fuel out of the airplane, not all of it, but most of it. But then you jump not in a technical challenge, but then you jump into a political tax structure that makes it impossible, because the fuel is added to the airplane without taxes being paid, because it's been part of international trips. Therefore, there is no tax obligation. But if you stop flying, you take the fuel out, then you can't reuse that fuel relatively easy on other airplanes flying. It is possible, but the cost of that is relatively high. So therefore, it doesn't really happen. So the only thing you can do is dispose of the fuel, and it will cost you money. Which is still very strange, but it also depends on the country where you are. But yeah, that is a good example of not only technical challenges, but also legislation challenges on how to improve the recycling of the fuel from airplanes that stop flying. So Aethos, as mentioned, will only focus on better solutions for materials currently reaching end of life. So as mentioned earlier, we are not trying to solve a replacement material. We're just trying to find the solutions of the materials that are now being used. Airplanes are flying. What can we do? So what is the goal? Funny enough, a lot of people that are working in aviation understand aviation. They less understand recycling. A lot of people that understand recycling don't understand aviation. And that's why this foundation is here, to build a bridge. Because both is required to better understand. So we're going to build a bridge between the recycling people who wants to learn more about aviation, but also the aviation people who want to learn more about recycling. And hopefully they can shake the hand and develop something that increases the recycling of materials from airplanes that stop flying. And to be clear as well, we're focusing on all solutions that might be available, but we only believe that the model that doesn't cost anybody anything will be successful. Because if we would introduce something that the owner of the aircraft needs to pay more or get less money for the airplane he's selling, then he probably doesn't want to. So the only solution that might work are those solutions that will not cost extra money for the people who are disassembling it, because if they have the extra cost, then those airplanes will be flying somewhere else. And the owner will also, that are selling the airplanes, will also not want to get less money for the airplane they're selling. Next to that, obviously, it's also about recycling, downcycling, incineration, or landfilling. If we can get material to move from incineration to downcycling, that's already a profit. That's already a gain. That's already something very important. Of course, recycling would be the best. Recycling meaning melting aluminum in such a way that you can produce aircraft parts from it again. That's the closed loop cycle. But if that's not possible, we can downcycle. That's already better than incineration, and incineration is also better than landfilling. But the only successful solution is a process that doesn't cost anyone, as mentioned. That is what it's about. We need to make sure that the solutions that we are trying to figure out is how can we do it in such a way that it doesn't cost anybody anything. And let's be clear that we're not only talking about the direct cost of the project, but also the indirect cost. Because if the company that is disassembling airplanes also can dispose of that waste in the same way or the same cost, if it will cost them more headache to separate it, more manpower, more time, then there also needs to be some compensation for that as well. So this is my presentation. You might be wondering if you could help me or Aethos, obviously. So join our network of friends. You can follow us on LinkedIn. You can also drop us an email, and then we can put you on the list of receiving emails. We're going to send our first newsletter in the incoming months. Approach us with ideas that you might have. Yeah, share with us the questions that you have if you are already in aviation, and you, but also the other way around. If you have an idea that you might think that is something that aviation could help forward as well, let us know. We as a foundation want to build a bridge, but also help those research to be done. We have money available to fund the research, so let us know if we can help you. And that was my presentation.
Thank you very much, Derk-Jan, for...
Lucky enough, somebody's talking to me, because I wasn't even sure it was still working.
Yeah, it feels a bit like COVID times, right? Where you're not really sure
exactly,
whether your students are paying attention, etc. So yeah, no, but I'm sure we all listened with great interest, because I think a lot of the things that you showed are what I find interesting is that a lot of things that you showed are kind of you can also apply to other industries, but there are also some very specific things for this aviation sector. So I learned a lot, at least. So thanks for sharing your ideas here, Derk-Jan. Yes, I would just like to open the floor for discussion. So if anybody wants to raise a question, just raise your hand, or also type something in the chat. I already see Sergio here.
Yes, so there again, thank you for a very inspirational talk, very informative as well. I wanted to pick up on one of the last things that you mentioned about the carbon fiber reinforced polymers plastics, because that would be then the next generation of planes, and that would be, there's definitely on the recycling part of the material, a key issue. Even though it's a small percentage, it is very symbolic to a certain extent. And you did mention that currently there are no good solutions, so it's more like landfill at this moment. That's what I understood. But what about, are you aware of any large-scale plans to downcycle the material instead of putting it in just land as landfill?
So during my graduation project, I did a trip with somebody from Boeing as an internship, because they were already trying to figure it out. So that's 2005, and already there was some military waste. There was also carbon fiber, so there were already tests being done. So yes, I do know that there are technical solutions where, and then the word downcycling, so that they can turn it into fibers that then can be used in producing something else. The challenge is in getting that process working. So technically, yes, there is a solution of at least doing something with it. And yes, it's not recycling because it's already, the fibers are already cut, meaning that you can't use it for an aircraft part. But the biggest challenge, as far as I understand, is that the predictability of the quantity is not high enough. Because if you, for example, can use it to produce something, I don't know, a car part or maybe a part of the interior for an aircraft or a computer or something like that, the producers would say, look, I need to be sure that I got enough of that flow to be able to produce enough of that stuff so that I can sell those items I want to produce. And that's where the challenge then comes up, because if all of a sudden more airplanes stop flying, there is more of that stuff. But if all of a sudden the production has issues, then everybody extends their life, and the availability of that scrap, that metal, that's not metal, that scrap material is then all of a sudden not there anymore. And if you produce something with metal, then you can have virgin new metal versus recycled metal. The cost difference is relatively low. But if you, for example, chop fiber and produce a computer part for it, then if you don't have enough of that waste, you need to buy also the new virgin material. And that chopping that up, that multiplies the cost significantly. And that's the big headache, as far as I understand.
Okay, thanks.
Thank you. John Allen.
Yes, also from my side, thanks a lot for a very insightful and inspiring presentation. I was wondering, in a number of sectors, people kind of mention this idea if they need material passports because you get a product and you don't actually know what's in it. You have a part, but you don't know what it's made of. Is that something that's also still an issue in aviation, or do they say that, okay, everything is so well documented, we're pretty sure, this panel is this alloy, that panel is that alloy?
That's also one of the subjects that the foundation is working on. So the idea is to build a database about information of what material is in what aircraft. To be clear, we also want to protect the people who are manufacturing that stuff, there, especially in the plastic area, in the metal area, it's very often known where what metal is used because of also the repair that needs to be able to be developed. So therefore, it's relatively easy to find, a little easier. But if you look at certain plastics, and I am not very well known in that area of materials, so I just use one word, plastics, and I know there are also a lot of different types. But yeah, it's a known fact that that is not being shared, and they don't share it to prevent somebody else to also make that part. So that's why it's not available sufficiently enough. So yeah, that's one of those challenges to convince aircraft owners, mainly the manufacturers or the parts manufacturers, that you need to share this material type that you are producing so we can recycle it, or you take the obligation and you just take everything back and then you organize yourself. But it means that the cost of collecting it and getting it to your facility or facilities, then you can maybe recycle it yourself. But that obligation or that initiative, I don't understand anybody. I haven't heard of anybody yet that they are saying, okay, I'm not willing to share what it is, so that means I'm responsible for it. They haven't done that yet.
Okay, clear. Thanks.
Thanks. Don't hesitate to raise your hand if you have a question. In the meantime, I have a question about the recycle. Well, basically the reuse of parts, and you explained very well how it's so important to have all the information indeed available, because all these parts have a certain lifetime, so you have to have a paper trail of exactly how long it was used for, etc., etc. I know a bit about the recycling of car parts, and I know there's a very much alive industry if it comes to the remanufacturing, but also refurbishment of old car parts and selling them again, and there's a whole internet marketplace for that. So is there? I guess there is a lively market for these airplane parts as well. Have you looked at the similarities and dissimilarities between those two markets?
Yeah. So what's the name again? The Dutch Association.
ARN.
Yeah. I talk to them very well. I know them very well. I'm talking with them as well, for example, on the recycling of batteries. Because they are also active in battery recycling, as in maybe batteries from aircraft can also be recycled. One of the funny things is that aviation, most airplanes fly with old battery models, so that has to do with the certification of that process, and yeah, it's easier to keep on flying that is certified versus replacing it with a better battery, lower weight, more energy. So yes, there is always talking with them. And it's great to build a bridge with them, but yeah, the materials are different, and also the decision model is different, and so they are also confronted with the challenge of cars being sold as a car being used in another country. As a result, it's not a recycling challenge in the Netherlands, but yeah, airplanes can fly even further away, much easier than a car can drive far away. So yeah, we're talking to them, and to be clear, I am enthusiastic that aviation is very good in the reuse of parts. But if you look at the way recycling works, the car industry is way further and way more developed than the aviation sector is.
Yeah, thanks. Peter.
Yes, hello, Derk-Jan. Thank you very much for your presentation. I really like the realism that you show in your approach. You explained that the volumes of recycling materials from aviation is very low in the total volume, but the exposure to the public is high. Does that play a role in this market or in the recycling? Does it play a role for operators? What happens? Do they want to publish? Do they want to use the exposure to the public? Does it play a role in this market?
I'm hoping that also the research we're doing will shake them up and gives them the idea as, okay, I might get a little bit less money for the airplane, but I will know that they will recycle better. And I can share with you an example. When I started AELS in 2006, a Dutch airline, without mentioning the name, said, I'm not going to do business with you because I want my airplane to be scrapped far away, because that will potentially be negative news nearby where my customers live, most of my customers live. A few years later, then they said, yeah, okay, we're willing to do it with you, but then we don't want everybody to know that we were involved. So yes, there might still be the color of the airline on there, but they said, we sell it to you, meaning that we're not responsible for what's happening with it. So they want to step away from it, but they were okay with it doing it more nearby, because also the cost of that, the flight is then lower, right? Now, the airplane I just showed you from Transavia, they are now officially sharing with everybody that follows them on LinkedIn that they are happy to recycle an airplane according to the high standard that AELS is already trying to do, and they also trying to raise the bar. So that is already a step forward, and I'm very proud of that airline making that decision, as in, okay, we also want that airplane to be recycled correct. So yeah, let's hope that this is the next steps, but that also requires research and stories and explanation to everybody who is active in that, and that's what we're trying to do, shaking up, building a bridge, the knowledge and the people who are actively involved in it.
Thank you for this explanation. I did not realize that the effect can even work the other way around. That's where you started long ago.
Yeah, I can share the frustration of being allowed to get I even I could not even buy the airplane. Even if I would pay more for the airplane, they still would not sell it to me, because I said we don't want it to be nearby where the airline is located.
Well, thanks for sharing.
Yeah.
Yes. Hi, Derk-Jan.
Hello.
Thank you for explaining. It's nice to get to know a bit more about the background and where Aethos came from. We're also looking into harvesting parts in the sense of panels and other construction elements from such complex structures and shapes. So I was thinking of chopping up an airplane much in a way that you would do with a tree. So we'll scan it, see what kind of parts we can extract from there and reuse those. I'd like to pick your thoughts on that. What do you think of such an approach? What do you think as opportunities of risk or risks?
So if you're looking at reuse of parts, aviation is already very advanced. That is because the availability of spare parts is always a challenge, and especially when manufacturing stops. If a part breaks, you need to call the manufacturer, and they'll say, yeah, we're now producing another version. You want the older one, we can make one for you, but it will take 6 months, and that just takes too long. So that's why the reuse of parts is relatively high. To be clear, then we're talking about the life limited parts, because those are, but also the rotables. So those are the parts that can be repaired and recertified. You also have consumables, and consumables are only used once, and then they are thrown away. And yes, there is some components in the middle. So if you are capable of increasing the reuse of consumables, that would be perfect. But there is a lot of aviation rules to make the safety of flying as good as possible, and that's blocking stuff. So yeah, if I can help you with a little bit more details or some extra background on specific details, I would happily do that. And if you have a question that I don't know the answer for, I would love to help you find somebody who can share that expertise or that answer that you're looking for.
Thanks.
That's what the foundation is for. I'm not smart. Yes, I did aerospace engineering at Technology of Delft, but I'm not one of the smart guys that were there. I'm just one of those.
Well, and actually, the one thought we had was to, for example, if we have the fuselage, we'll cut out curved panels from that and then reassemble those in a way that we can reuse them in another application. So that's not really reusing in aircraft, but repurposing elsewhere.
That's alternative reuse. That's not something that, and I always use the word alternative reuse because I started using that, and these days they use refurbishing, I think it's the term they're using. Also perfect, but aviation is unique materials, unique paint being used, making that stuff more challenging. And also for that type of process to have a predictable quantity of the flow so that you can get that machine you're developing to keep on working. That is the same challenge that I just mentioned with the carbon fiber reinforced plastic recycling process. So yes, is it one-off, as in you just want to build a nice aircraft next to a hotel? Corendon, you might know that airplane, that 747. I was part of that group that got that airplane there, and that they're now being used for fun. Those things are perfect and can work, but if it's a long-term repeatable solution, that's extremely challenging.
Thank you. And thanks to you all for joining. I think this brings us to the end of this this talk. Thank you again, Derk-Jan, for sharing your insights. I think it was a really inspiring talk, and great that you put so much energy into this this very valuable initiative. So thanks for sharing your insights, and and thanks for all that participated, and hope to see you next time.
Sounds like a lot of fun.
Okay.
Thank you all for listening, and if you want to know where to meet me, you can find me somewhere, and also give me a call or send me an email, something like that. And I would love to talk to you and see if Aethos can help you do research that will help the aviation sector step forward.
Thank you so much, and thanks all.